Welcome back. How are you feeling after the last quiz? We're starting to learn some pretty cool things that we could do in our code, right? And who knew loops could be so fascinating? We've now discovered two looping techniques that we could use in Python: while loops and for loops. We use while loops when we want to do an operation repeatedly while a certain condition is true. And we use for loops when we want to iterate over the elements of a sequence. Now, we're going to check out a third technique called recursion. But before we dive in, you may have noticed that this video is marked as optional. That's because while recursion is a very common technique used in software engineering, it's not used that much in automation. Still, we think it's valuable for you to know about recursion and to have an idea of how to use it. You may see it in code written by others, or you may face a problem where recursion is the best way to solve it. So while the next few videos are marked as optional and you won't be graded on their content, it's still super valuable stuff. Of course, feel free to skip them if you'd just rather focus on concepts you'll be graded on. Let's dive in. Recursion is the repeated application of the same procedure to a smaller problem. Have you ever played with a Russian nesting doll? They're a great visual example of recursion. Each doll has a smaller doll inside it. When you open up the doll to find the smaller one inside, you keep going until you reach the smallest doll, which can't be opened. Recursion lets us tackle complex problems by reducing the problem to a simpler one. Take our Russian nesting dolls, all nested inside each other, and imagine we want to find out how many dolls there are in total. We would need to open each doll one by one until we got to the last one, and then count how many dolls we've opened. That's recursion in action. Here's another example with a more complex problem. Imagine you're in a line of people and you want to know how many people are in front of you. And let me tell you, I can't stand long lines. Anyway, if the line's long, it might be hard to count the people without leaving the line and losing your place. So instead, you could ask the person in front of you how many people are in front of them. Since this person will be in the same situation as you, they'll have to ask the same question to the person in front of them. And so on until the question reaches the first person in the line. This person can confidently reply that there are no people in front of them. So then, the second person in line can reply 1, the person behind them replies 2, and so on until the answer reaches you. Okay, I know the chances are pretty small that all those people would play along just so you can know where you are in line, but it's a useful way to visualize how recursion works. How does this translate into programming? Well, in programming, recursion is a way of doing a repetitive task by having a function call itself. A recursive function calls itself, usually with a modified parameter, until it reaches a specific condition. This condition is called the base case. In our earlier examples, the base case would be the smallest Russian doll, or the person at the front of the queue. Let's check out an example recursive function to understand what we're talking about. Here, we're defining a function called factorial. At the beginning of the function, we have a conditional block defining the base case, where n is smaller than 2. It simply returns the value 1. After the base case, we have a line where the factorial function is calling itself with n minus 1. This is called the recursive case. And this creates a loop. Each time the function is executed, it calls itself with a smaller number until it reaches the base case. Once it reaches the base case, it returns the value 1, and then the previously called function multiplies that by 2, and the previously called function multiplies it by 3, and so on. This loop will keep going until the first factorial function called returns the desired result. It's a bit complex, right? Let's add a few print statements to see exactly how this works. So here we can see the function kept calling itself until it reached the base case. After that, each function returned the value of the previous function multiplied by n until the original function returned. Cool, huh? Next up, we're going to check out some more examples of when to use recursion and when it's best to avoid it.